Now we'll see some useful things about this linked list. One is implementation of stack. We can implement stack very effectively. So generally, what is stack? Stack is a dynamically growing data structure, right? That means we insert data, after that we delete. Then we don't require fixed space. That means our requirement grows and shrinks. When that is a possibility, then if you try to implement your stack using a rigid array or fixed size array, then definitely you face problems, right? That's why here linked list will be the best thing, where linked list is dynamically growing data structure, right? So in linked list also, at any time we can add data, right? At any time we can delete the data. That's why I can say that I use linked list to implement stack. So definitely I will get best possibility. How to do that? We'll see. First, we try to understand stack. In stack, what is happening is we are storing the data like this, right? 1, 2, 3, 4, 5. After that, we have to delete the recent data. Then somehow you try to collect this data using linked list nodes, but such a way that always try to have top element at in front of the node, I mean in front of the list. If you do that, it will be easy for you to delete. Example, you see this one. First time whenever you push a data into stack, what I do is I create a node into linked list. And whenever you push one more data, then rather than inserting it after one, I will try to insert before one. So that is also known as insert in front, right? Example, you have data like this. Then apply insert in front method. Whenever you insert in front method to this linked list, what happens? 2 comes here, after that 1 will come, right? Then here null, of course. Now if I insert one more data, then what happens? I apply here insert in front, then what happens? 3, after that 2, after that 1. In that way we can continue. So if you do 5 times, what happens? You get this kind of linked list: 5, 4, 3, 2, 1, right? Now this is your start. My question here is how to delete the data. To delete the data, what I do is I take one temporary variable and I keep it to point first node. After that, what is my target? I would like to delete 5. Then after that I would like to increment start. So let's increment start first, then start comes here. Pretty good, that is very easy. Then after that free temp, then you lose 5, then remaining thing is 4, 3, 2, 1. It is exactly representing pop, isn't it? But for that we have to move your start. Already I told you, whenever you want to modify start through another method like pop or anything, then somehow you should pass the address of start, correct? That's why here your requirement is we have to pass address of start to the method. Now what about push? Push is very easy, already we have implemented, that is insert in front. So simply replace your push method with insert in front. But insert in front, of course we know that already I implemented. Insert in front also going to modify your start. That's why the possibility is sending address of start, that is compulsory. And what is the other thing you should send? Value, right? So simply value. Whenever you do insert in front with start and value, what happens? Data will be inserted, right? Already I implemented it, remember it. Now we'll see how to implement pop, which is nothing but you know deleting the data, right? So I write struct node pointer. Let's say, what is my expectation? Someone has to give starting node of the linked list, correct? So from now onwards what we do is, for readability, otherwise for maintaining the semantics of stack, I will do one thing. Rather than using stack, we use top. Okay, so from now onwards my start is top. Okay, example, in this one it is 5, 5 is linked to 4, 4 is linked to 3, 3 to 2, and 2 to 1. Okay, this is your linked list. So how to implement pop, we'll see. So I am going to modify this top, isn't it? That's why send address of top. Who is capable of taking address of top? What is the data type of top? Already I told you, it's a struct node pointer. Then here we need struct node double pointer for maintaining the semantics, because this top is resembling that top. It is going to take the data from that top. Let's use same variable name so that it will be meaningful. Your method will be meaningful. So second one is what? Pop doesn't require anything, only top, correct? Because we are going to delete the value. start. What is the first line? See the picture and tell me. In our deletion or in pop, we are going to have a temporary variable to remember this box because we are going forward, right? So first step what we do is simply take one variable temp. I am not mentioning the type of temp. We know that temp should be what? What is the purpose of temp? It should remember this box. For that, temp should be struct node pointer. That's it. So I can say struct node pointer temp equal to Mr. Temp, please hold top. But here we have this top. Is this top and that top same? No, right? What is the relationship between this top and that top? Simple. This star top equal to this star top, let's say equal to that top. Okay, so this top is old top. I can say this is new top, but we have now new top available, but I would like to write a logic with respect to that top. So if here actually we have to write that top, but we can't write it, but we can write this new top. What's the relation between these two p's? Star top equal to top. Then simply mention this as star top. When you do star top, automatically this star dereferences this top so that you will reach this top. Remember. Now what is the next step? Next step is, now your temp is going to hold this box, then we are going to increment this top. But be careful, this top is different from our top. We have address of top. That means we have, our new top is going to point to this one. Then whenever you want to access it, you say simply star top. Ready? Now what is your goal? You want to move Mr. Top to here. For that, using this, then simply write star top equal to, then automatically you are accessing this one, equal to dash top cap next. First of all, I will tell you one easy technique. Forget about this one. With respect to this one, what do you want to say? Top equal to top cap next, correct? So first you write logic with this top, then convert it to this logic. With respect to this top, the same thing can be nothing but star top equal to star top cap next, right? So better what we do is, when you have multiple operators, if you don't know the priorities, you just guess. I mean, otherwise you tell me what is to be done first for you. For you, star top should be, star top cap next should be accessed. That means you want to have priority here, right? You don't want to have top cap next star, correct? So what is your intention? You want to go to next, next of star top. That's why put brace like this, so that it will be safe. So star tops next. What is star top? This one. This tops next, right? So next step is what? Now top is incremented. After that, top comes here. Then you have to free this temp, correct? Before that, if you want to take the data, then take one thing, like create a variable x, int x equal to, what is that data? Where is that? In temp cap info. Pretty fine. After that, what you would like to do? You would like to free that temp. Then simply write free. That box is now pointed by temp. Free it. Then what else you want to do? That's it. Already top reached to right position, and this box is deleted, and the deleted value we have stored in x. Then simply return x. Then what should be the data type or return type of this method? Definitely integer, because sometimes we are returning x. But are we covering all the cases? We should check. What is that? What does it mean? Are we covering every case? Whenever you have single node, will it cover? We'll see. What happens? We'll see. So if you implement something, then we have to run this method for some cases and we have to check. That would be better. Example, initially your top is pointing to only single node, and which that single node, so next is null. Here you have data 1. Then I'm going to pass this to this one. Okay. So you tell me what is the content of top. Exactly this box address. This box address, let's say 700. Then this will be what? 700. This top's address also we are using, let's say 800. Right. So when you call pop, you will be calling like this pop. And since top is a double pointer, we have to send this address of top. We know the syntax. We are going to send address of top, comma, value. Which value? Any value? Nothing. So only one thing. So when you call like this, what happens? We'll see. Blindly execute this code. Ready? So this top is going to have what? Content of top is nothing but address of top. Address of top is what? Top is this one, then address is 800. Next, come here. Directly you do this step. Temp equal to star top. So temp is going to be dash star of top. This top, star 800. So value at 800, value at 800, 700. Then I can say that pictorially your temp is pointing to this box, right? Next, star top. So from now onwards, star top always will become what? Star 800, 700. That means we refer this box, correct? So from now onwards, whenever I write star top, you feel like we are referring this box, okay? So star top, this one, equal to top, star top cap next. What is star top? Again this box, cap next is null. So better, so whenever you see star top, so from now onwards, star top is always top. So star top behaves like top. Then when you see star top, feel like you have top, okay? This top. Now top equal to top cap next with respect to this one. Then what happens? Top will become dash, top cap next, null. So this top will be updated. We know that. The reason star top is nothing but that top. Next, int x equal to temp cap info. So x equal to temp cap info. What is temp cap info? 1. X will be 1. Then free temp. So we are freeing this temp. Temp is now pointing to this box. Then this will be freed. After that, you return x. But one mistake you are doing, whenever you do all these things, yeah, are we updating our top, this top? Yes, we are updating this top. So there is no mistake. Generally, you should be very careful. So finally, this box is deleted and top was pointing to null. That means when you have single node, it was working. When you have multiple nodes, we know that it works. Now, we have to cover last case. What if already your stack is empty? Will it work? Then definitely what happens, you see. First step itself, what you are doing is struct node star temp equal to what? Star top. What is star top? Is that top. The top is already pointing to null. Then temp will become null. Then what are you doing? You are incrementing top. Correct? Which top? That top. When already top was pointing to null, then when you increment that, you get segmentation fault. Remember one thing. Accessing null and accessing null cap next or null cap information always gives segmentation fault. Here it is like star top is null. Null cap next always illegal. It gives segmentation fault. So this code will not work. And we know the reason why. When there is no node, how can you pop an element? That's why here we should write a border case. That is, if star top means that top equal to null, then what to do? Nothing. Stack is empty. Correct? So either implement stack empty separately, otherwise you write this star top equal to null. Let me implement that stack empty separately. I use that method. So what I do is, if I write this code is stack empty, okay, so is stack empty, and we pass star top. So this stack empty method I am going to implement, that is going to check whether your stack is empty or not, okay. And what is star top? That top. We are passing again that top. So if is stack empty true, then simply exit. Don't do anything wrong. Otherwise continue. In that way we can do this code, okay.